One of the key building blocks of cloud is virtualization. What is virtualization? Let's talk about that through an analogy. I'll give you a basic example. Let's consider that you have a piece of land and you have to accommodate a family on top of it, like they want to live on this piece of land. One option for us is that we could go ahead and build a house on that piece of land. Obviously, this is how we started initially as humans. We started building house, and then one family would be sufficiently probably staying into this house without any issues. But as the livable land is less and people are growing all the time, what we need to come up with a better way of utilizing that space, and that came the idea of creating these buildings. So same piece of land, here it is one single family is living, and here probably in every single apartment there are families living in. So obviously we could accommodate more people into this building. That is the same idea of virtualization in a nutshell. What we have here, that initially we had one single server and on that we were running one application. Now we are trying to put more application but still in isolated fashion. Like here, if you look here, then every family who is living here, they have their own isolated space. Obviously there are some common things they are sharing, but maybe this person want to have wall of the color of the wall green, they can. Another one thinks no, this color would not work for them, they want a yellow color, they could go for it, should not be a problem. Within their space they can change things, should not be an issue, and it should not be affecting the others. That is how the isolation has been created. Same thing happens into virtualization. Let's try to understand in technical perspective now. So in legacy data centers, what we used to have, used to have one-to-one mapping of application. What we mean by that, that one application and one server. So we have one physical server, we will make it a web server, another server maybe database, and so on. Why this one-to-one mapping was created? Because there were a lot of compatibility issues. So let's say if I have one server and on that I install the web server software also and database server also. Now what if I have to patch the web server or a database, I have to reboot the server and it will create problem. Or if web server crashes or it has some compatibility with Java which is not working out, it may affect my databases also. So in initial days, we started creating one-to-one mapping to keep things in as isolated as possible. That was a good approach, but the challenge with this approach was that we were not fully utilizing that particular server. Industry average is 10 to 20% utilization of a physical server, and that's what happened here. Like we could see, some servers are very less utilized, whereas some may be high, and most of them are very low utilized. So that is not very efficient use of resources. What we end up in the situation are low utilized server. All these servers are consuming space, they are consuming power, they require cooling, they require maintenance. So that was not very efficient approach. Now, let's try to isolate ourselves from servers. Let's focus on users first. If I'm a user, I am interested into running or accessing my application. Now, if I am accessing that application, if it is working, I don't care what is in the backend is powering it up. Like when I'm using, let's say, recording software, or I'm using WhatsApp, or I'm using a browser, I don't worry about what is running behind the scene for my banking application. So users care about application. And what is required to run an application? To run an application, we need initially hardware resources. That hardware resources are your CPU, your display, and then your disk and network connectivity. All of these physical hardwares are required. When we have this physical hardware, on top of it, we install a common operating system like Windows or Linux or Mac operating system. And once this has been set up, I would be then hosting my application, maybe mail server, maybe databases, maybe shopping cart. This is what our application stack on a high level looks like. So in a traditional approach, what we had a tight coupling of a hardware and operating system. On one hardware, we would have one operating system. Let's say it is Windows in this case. It would control all the hardware associated with it. Means CPU, memory are controlled by Windows that it utilizes it. So this is what we mean by a tightly coupled architecture where my operating system is tied to or chained to a hardware. That's how we used to work. When virtualization came in, virtualization tried to create isolation. In a very basic sense, if I say what is virtualization, virtualization is basically isolation, and the main idea was let's remove this dependency. So virtualization decouples the hardware from operating system. We are trying to create a isolation between these two, and how you create isolation between a hardware and a traditional operating system, we install or we manage a virtualization layer. So we introduce a virtualization layer between hardware and the operating system. Now, because of this virtualization layer, your physical hardware is being treated as virtual hardware, or this CPU becomes a virtual CPU, this disk becomes a virtual disk, memory becomes virtual memory. So this virtualization layer basically created virtual hardware out of physical hardware resources. And now once you have this virtual hardware resources, we can present this virtual hardware resources to our virtual machine, or the isolation we created. So application requires operating system. Operating systems require hardware. Now instead of providing a physical hardware, we have provided virtual hardware to it, and now we could have created isolated virtual machines on which my application can run. So virtualized hardware resources can be assigned to different virtual machine, and now you could decide, okay, in this place I want to have Java as an application, and maybe I want to keep my operating system as Windows. Another place I may want to have my application which is going to be let's say a banking application, and I want its operating system to be Linux or any other type of thing. So that should not be a problem. So we could go ahead and use different operating system, different application combination in this way. So now on the same hardware we are able to host multiple virtual machine, and they can run their independent operating system, and application should not be an issue. So in virtualization approach, we focus on these four core component. Those core component are your CPU, so that becomes virtual CPU, RAM becomes virtual memory, disk become virtual disk, and network interfaces become virtual network interfaces card. And through this, we are able to provide resources to the operating system when they need it. And benefit of this approach is, now instead of having individual server which are consuming less or which are utilizing less hardware, instead we could have one single server and use these machines as virtual machines. And now because we are putting more pressure or more load on the single server, its utilization will be higher, and that's how we are able to get the most optimal result from the money we invested into this hardware. So in the same piece of land, now we can accommodate more families. As per my analogy, previously it was just one single family living in, but obviously there are some challenges. We will be talking about them as we move forward. Now you may be thinking that what is the enabler for virtualization? What made it possible? The technology which we could have utilized this kind of approach. Like in old days, we could not have imagined to build a 20-story building or even a 2-story building. But later, as the technology evolved, we are able to construct houses and buildings like that. Same way, the enabler for virtualization is decreasing cost of powerful hardware. I remember my old PC when I bought, it has around 133 megahertz of processing power and 8 GB or 16 GB of RAM. But now any small phone would have more processing power and memory than that. So cost of hardware is decreasing and hardware is becoming more and more powerful. So now that powerful hardware can be utilized to run multiple machines, should not be an issue. So that is on a very basic sense what is virtualization. Hope this thing is clear. We'll talk more about types of virtualization into the next section, so join me there. Thank you.